Okay, so basically we will be looking at the graphs of projectile motion. As you can see here, let me choose a pen. Okay, graphs of projectile what? Projectile motion. This is type to projectile shot up, then falls down. So here we'll be talking about the situation whereby a projectile is being shot up, then it has to also fall down. Like for example, you can have an object here being shot upward, then it will fall downward. We don't know whether it will fall at the same level or it will fall below its reference point. Remember, always when we're talking about um, a point where an object was released, we'll be referring to it as a reference point or a starting point. And at that point, you have to take in consideration that your displacement at that point is equal to zero. Let me then not just say displacement, let me just say the position, your y value at that starting point is equals to significantly zero. So we'll be looking at the projectile motion of an object which is shot upward, then it falls, right? Then falls downwards. So we don't know in which direction is this object. I mean, we don't know whether it will fall in the same level or below its original or reference point. Okay, let's take it. Let me wrap this thing for clarity. I'm gonna explain it into details. Please pay attention because this information that I'm gonna share today is very, very, very much crucial and important when you're in grade 12 and studying physics. Okay, let me zoom in a little bit, a little bit. Yeah, thank you. So here we'll be looking at three graphs of the same event. So basically, it's these three graphs we will be focusing on the same event, whereby an object is being shot upward, then it has to go up. It's either shot or thrown. Whether an object is thrown upward, is thrown or shot upwards, then falling back downwards. Sometimes an object can never be thrown or shot upward, but you have to take into consideration of the same features pertaining that particular problem. Let me give you an example. Maybe we have a hot air balloon which descends upwards. Okay, this hot air balloon descends upwards. Okay, I'm not good in drawing, but I'll try. This is the hot air balloon descending upwards. Then they drop an object. Remember, this object will firstly move upward, then before it start going down. So this problem or this situation, it pertains to the same situation whereby an object is either thrown upward or shot upward, then it falls downwards. Those are the principles that you have to take into consideration. The reason why in a hot air balloon or anything that is moving upward, the object when it's raised moves upward before it goes downward, it is because of Newton's third law. Newton's third law. It states that when object A exerts a force on object B, object B is simultaneously exert the same force of attraction on object A, meaning the force at which the hot air balloon moves upward, it will be exerted on the hot air balloon, causing it to go upward before it goes downward. So we're gonna be explaining more into details when an object goes upward and it reaches a point where it has to descend. So now let's take a look at a displacement time graph. When we're looking at a displacement time graph, we have to know that if from a reference point is starting zero, the displacement increases until it reaches a maximum point, like reaches maximum. When the displacement reaches maximum, it will start to decrease, going downwards in a negative direction. So basically, the displacement it will start and increase after increasing to reach maximum, then it start to decrease in an opposite direction. So basically, in this situation, we look at it upward as positive and downward as negative. You feel? So that's why the graph, the displacement, when it moves upward, it became positive, then reaches a maximum, then it moved downwards in a negative direction. Displacement just shows the motion of an object, that this object moved like this. You get it? That is the displacement. The object moved like this. As I always say, the motion of an object goes hand to hand with the displacement. If an object is going upward, displacement is going upward. Okay, let's take a look at the displacement. This is the displacement increases in a positive direction until it reaches maximum. Then it decreases. It becomes negative if it moves below the starting point. So basically the displacement, it becomes negative when it moves below the starting point. But according to my perspective of how I view vertical projectile, means that immediately it turns. If upward is positive and downward is negative, displacement start to move in a negative direction. Take in consideration this displacement time graph scientifically shows how the motion moves. Like they say, this graph tracks the position of an object thrown up, then falling in time. It does not mean the object is thrown in an arc. It does not mean an object is being thrown like this. No, it means an object is being thrown upwards. This motion, when it goes upward, then goes down. Get it? That is what this this graph scientific elements. Okay, so first another thing we'll be looking at a velocity time graph. Okay, this is one of the easiest graphs to understand. Velocity time graph. Velocity time graph, as I said, upward is positive, downward is negative. It will start to decrease when it moves upward. Remember, when you throw an object upward, it will start to move in a maximum direction. Maximum direction, I mean, it will start um, to move with the force at which you throw the object down upward. But from that instance, its acceleration tends to do what? To decrease until it becomes zero at the maximum point. Then you start to move in a negative direction. If you can see here, it was moving in the positive direction, meaning it's going upward because upward is positive. Here it's moving in a negative direction because it's going downwards, and downwards is negative. Right. And the other thing that you have to take in consideration is that at the maximum point, velocity is equal to 0 meters per second. Always at the maximum point, velocity is equal to 0 meters per second. Then let's take a look at the acceleration time graph. Okay, acceleration time graph, we're looking at a situation whereby the acceleration is always constant but downward. Gravitational acceleration is always constant, but it's always going downward, meaning an acceleration of a graph is always constant, but it's always going downward. If upward was positive, it means downward is negative. And from that instance, that's why we draw a straight line like this. So basically, these graphs are very much simple. You have to take in consideration in which direction that they move, the object is moving, and what is the direction of that particular um, object in that particular direction. So basically, here, if we choose upward to be negative and downward to be positive, the graphs are going to be opposite. If you can check the acceleration time graph, I mean velocity, I mean displacement time graph, displacement versus time. I'm just gonna write it like this to save time, right? So what is happening is, if upward is positive, remember we're holding negative numbers here, we're holding positive numbers because it's moving downward, and downward is positive, right? So basically the object, it will be in this manner. Then it goes upward. It will move in that manner. Why? Because upward it is negative and downward it is positive. And if you can take in consideration of what I just drew here, is that when the objects move from the starting point going downward, here will be having a positive displacement. But from starting here going downward, here will be having a negative displacement. Then from here, you can see good thing. Uh, wait. Let me see. Yeah, a positive displacement from here, negative displacement. As you can see, the object when it keeps on going that side, start to have a negative um negative um negative displacement. So basically it becomes an opposite of this one. This one is when upward is positive and downward is negative. This one is when upward is negative and downward is positive. So it will be like that. You just have to know this thing by heart. Secondly, when we're talking about velocity versus time graph, time graph, it will be like this. The object will move like this. And why? Because here, let me see something. They said here they choose. Okay, since we chose upward as positive, okay, upward is positive. Okay, so here, as you can see, its velocity, it will decrease going upward. Remember, here it is going upward here. Here it is going upward. So when it goes upward with a negative direction. Then from here it becomes positive because it's in a positive direction. Then from here is what we call the maximum point, max PT, because it's where the object reaches its maximum point. Then again, if you can check the displacement versus time graph here, it was moving upward in a negative direction. Then from here, start to move in a positive direction, going downward. Because remember, the motion, the object is being thrown upward and it has to fall downwards. Then acceleration versus time graph. Oh, this one is very simple. Acceleration versus time graph. Looking at it like this. Remember, downwards is positive. That means our 9.8 would be here. Then we draw it like that. Simple. The simple graph to draw is this one, that one. But even displacement versus time graph is simple. The only thing just to have to know which we draw which kind of a graph, what is it? If they say displacement time graph, when they throw an object upward, it becomes like this. Then we have to know even when we drop an object or when we throw an object downward, which we explained in our previous session. Okay. This is very, very much important. Here, open your ears and take into consideration because the information that I'm going to share here, it is there everywhere. So what is happening is this is a projectile projected vertical upward, which falls back to the same level. So basically here they threw an object from maybe point A and the object returns to point B. Basically point B is just the same level as point A at the same level. Basically the object just did something like that. So what is happening is this is we chose downward as positive. So basically the direction is downward is positive and upward is negative. Remember, in physics, direction is very, very much important. This is initial velocity is this at A. The object leaves at this certain point in an upward direction. So initial velocity is this one and it moves in an upward direction. That's why it's negative. Initial velocity is negative because upward is negative, then it takes negative direction. As negative as it is moving upward, the magnitude of the velocity decreases, the object rises. So always when an object is thrown upwards, the magnitude of its velocity keeps on decreasing and decreasing and decreasing until it reaches a maximum point where the velocity reaches its highest point where the velocity is equals to zero. So you have to know always that at the maximum point, velocity is equals to zero. Always at the maximum point, velocity is equals to zero. The velocity increases as the object falls downward towards the ground. So always, and the object when it goes up, its velocity decreases. Then when we start to go downward, its velocity start to increase and increase until it reaches its same level. So initial velocity is equal to the magnitude of the final velocity. So basically, when an object reaches this level, remember it moved from this level, immediately it reaches the same level again. Its velocity, its initial velocity, which is the velocity from this side, it will be equals to its final velocity, but in opposite direction because this one was moving in upward direction, then final velocity is in a negative direction. Okay, it will be in opposite direction. That's what I'm saying. So, or you can say here is positive, here is negative, depending on which one you choose to be. Because upward here is negative, then initial velocity to be negative, final velocity to be positive because it's moving downward and downward is positive. Right. So something that you have to know is that if an object moves from this point and arrives to the same level, velocity at B is equal to velocity at A. And velocity at A is equals to velocity at B. Only the magnitude, but directions they will be opposite because at A the object moved upward and it will take direction of upward. At B the object was moving downward, then we take the direction of downward, right? And the time taken for an object to move from point A to reach to point B is equal to the time taken for an object to move from point B to reach to point uh, C. So basically the time taken from A to B is equal to the time taken from B to C, which means the total time taken to move from A, B, C, it will be 2 times the time taken from A to B and 2 times the time taken from B to C, or is equals to the time taken from A to B plus the time taken from B to C. Always like that. The time taken for an object to reach its maximum point is equal to the time taken for an object to move from its maximum point and go down. This principle is always applicable everywhere, anywhere. That is very, very much important. As you can see here, this is the time taken to rise from A to B. The time is equal to the time taken to return from B to C. So the time taken for an object to reach the maximum point is equal to the time taken for an object to return back to the same level. As you can see, the total time, as I said, is equals to this time plus that time. So these times they're always equal. Then from that instance, we're gonna keep our information being like that. I don't know. The election, I don't know whether this will stop recording or whatever. It's this thing. Okay. And again, as you can see, the object displacement. Oh, yeah, crazy. Yeah, then.